Close your eyes now and breathe deeply. Let your body sink into comfort. Tonight, we're going to take a journey. A slow, peaceful journey on an escalator that moves through time and space, carrying you gently toward rest. Imagine yourself standing at the bottom of an escalator. It's late evening, and the world around you is quiet. The escalator before you glows with a soft, warm light. You can hear the gentle hum of its motor, a steady, rhythmic sound that's almost like a lullaby. This sound has a frequency of approximately 60 Hz, the same frequency as the electrical current that powers it, creating a consistent, soothing drone that helps your mind begin to settle. You step onto the first moving step, and immediately, you feel the gentle motion carrying you upward. There's no effort required from you now. The escalator does all the work, moving at a calm, steady pace of about 0.5 meters per second, roughly 100 feet per minute. This is the standard speed for most escalators, carefully calculated to be fast enough to be efficient, but slow enough to be safe and peaceful. As you rise, let yourself notice the handrail moving alongside you. It travels at precisely the same speed as the steps beneath your feet, synchronized through an ingenious system of chains and gears. The handrail moves at exactly 0.5 meters per second, matching your ascent perfectly. This synchronization isn't automatic. It requires careful engineering and regular maintenance. The handrail is typically made of a rubber canvas composite, reinforced with steel cables, designed to be both durable and comfortable against your hand. Feel the texture of that handrail beneath your palm. It's been carefully designed with a coefficient of friction that's just right. Not so smooth that your hand slips, but not so rough that it's uncomfortable. The surface has been treated to resist bacteria and maintain cleanliness. As millions of hands have touched this rail before yours, it's been cleaned and sanitized thousands of times, each cleaning keeping it safe and pleasant for the next person's journey. As you continue your gentle ascent, let me tell you about the very first escalators, about how this marvel of engineering came to be. The story begins in the late 19th century, in an age of great invention and innovation. The world was discovering electricity, and engineers everywhere were dreaming of new ways to move people through space. The first working escalator, or what was called a moving stairway, was invented by Jesse W. Reno in 1891. But Reno didn't think of it as an escalator at first. He imagined it as an amusement ride, something thrilling and new. His design featured a moving ramp with a 25-degree incline, powered by an electric motor. The treads were made of wooden slats, and the entire contraption moved at a leisurely pace. Reno's escalator made its debut at the Old Iron Pier at Coney Island in New York in 1896. For a week in September of that year, thousands of people paid a nickel each to ride this mechanical wonder. They would step onto the moving ramp at the bottom, hold onto the handrail, and experience the strange sensation of being carried upward without climbing. It was magical. It was revolutionary. In that single week, more than 75,000 people rode Reno's escalator, delighting in the effortless ascent. Breathe deeply now, and imagine yourself among those early riders, experiencing that first escalator. The excitement, the wonder, the slight nervousness of stepping onto a moving platform for the very first time. But also feel the safety, the steadiness, the reliable mechanical rhythm that carried them upward. Around the same time, another inventor named Charles Seeberger was working on his own design. Seeberger's vision was different from Reno's. He imagined flat steps, actual stairs that moved rather than a ramp. In 1899, he created the first working model, and by 1900, he had partnered with the Otis Elevator Company to manufacture his design. The word escalator itself is Seeberger's gift to us. He combined the Latin word scala, meaning steps, with the word elevator. Escalator. The name perfectly captured what the device did. It was a moving stairway, an elevator made of steps. Otis trademarked the name in 1900, though by 1950, the term had become so common that it entered the public domain, becoming the universal name for these moving staircases. The first Seeberger escalator was installed at the Paris Exposition of 1900. Imagine that moment, the grand unveiling at T, the World's Fair, where nations gathered to showcase their greatest achievements. The escalator was there among the other wonders of the modern age, and people came from around the world to ride it. As you continue your peaceful journey upward, picture that Paris exposition. The year is 1900 and you're walking through the grand pavilions. You hear music, voices speaking in dozens of languages, the excitement of discovery. And then you see it, Seeberger's escalator, rising smoothly toward the second floor of a building. A small crowd has gathered to watch it in operation. You join the queue and wait your turn. When you finally step onto that first moving step, you feel the same sensation you're feeling now in your imagination. The gentle forward motion, the steady rise. The steps beneath your feet are made of wood, carefully crafted and polished. They emerge from beneath the floor at the bottom, rise upward, then disappear again at the top in an endless loop. The Paris escalator was 25 feet tall and could carry about 4,000 people per hour. That might not sound like many by today's standards, but in 1900, it was extraordinary. Before escalators, if you wanted to move thousands of people up to a second floor, you needed a wide staircase and a lot of patience. The escalator changed everything. The first escalator in the United States was installed in Philadelphia in 1901 at Gimbel's department store. Then, in November of 1902, the first escalator came to New York City, installed at Macy's on 34th Street. This was a momentous occasion. The management at Macy's was so concerned about customers being nervous about riding the escalator that they stationed a man at the top with a glass of brandy and smelling salts, ready to revive anyone who felt faint from the experience. Can you imagine it? The year is 1902, and you're a shopper in New York City. You've heard about this new marvel at Macy's. You enter the store with a mix of curiosity and trepidation. There it is, the escalator, moving steadily, carrying shoppers between floors. You watch for a moment, studying how others step on and off. Some people look perfectly comfortable. Others grip the handrail with white knuckles. Finally, you decide to try it. You time your step carefully, placing your foot on the moving tread. For a moment, you feel a slight lurch as your body adjusts to the motion. Your other foot follows, and now you're standing on the escalator, rising smoothly upward. The experience is unlike anything you've known before. You're being transported without walking, moving between floors without climbing stairs. It feels like magic, like something from a Jules Verne novel. When you reach the top, you see the attendant standing there with his tray, but you don't need the brandy or the smelling salts. You feel exhilarated, you feel modern. You immediately want to ride it again. Let yourself continue rising on this imaginary escalator. Feel the steady motion, the reliable rhythm. Now let's explore the beautiful machinery that makes this movement possible. Understanding how something works can be deeply relaxing. There's comfort in knowing that every sound, every motion, every sensation has a reason and a purpose. Beneath the steps you're standing on, hidden from view, is an elaborate system of chains, gears, and motors. At the heart of it all is an electric motor, typically ranging from 3 to 15 horsepower, depending on the length and expected traffic of the escalator. This motor turns continuously, never resting during operating hours. The motor drives a set of gears, specifically a gear reduction system that converts the high-speed rotation of the motor into the much slower, controlled movement of the steps. These gears are lubricated with special oils designed to work quietly and efficiently. The gear ratios are carefully calculated. A typical ratio might be 60.1, meaning the motor shaft rotates 60 times for every single rotation of the main drive shaft that moves the steps. The main drive shaft is connected to a chain drive system. Imagine 2 large sprockets, toothed wheels, one at the top of the escalator and one at the bottom. A continuous chain loop connects these sprockets, running in a circuit. Each step of the escalator is attached to this chain at precise intervals. When the motor turns the top sprocket, it pulls the chain, which pulls the steps, creating that smooth, continuous motion you're experiencing. But here's where the design becomes truly elegant. The steps don't just move forward and up. They also need to flatten out at the top and bottom so people can easily step on and off. This is accomplished through a track system. Each step has wheels, 4 wheels to be precise, 2 in front and 2 in back. These wheels run along 2 different tracks. The front wheels follow a track that rises and falls, creating the stair pattern. The back wheels follow a track that's parallel but at a different height. At the bottom of the escalator, the front and back wheels are at almost the same level, so the step is nearly flat. As the step moves upward, the track beneath the front wheels rises, tilting the step to create a stair. At the top, the tracks level out again, flattening the step for easy exit. Breathe slowly and imagine these wheels turning, following their tracks in an endless loop. Each step rises into view at the bottom, carries you upward as a stair, then flattens again at the top before disappearing beneath the floor to travel back down. The journey is circular. What goes up must come down, then return to rise again. It's a perfect cycle, endlessly repeating, like the rhythm of breathing, like the rhythm of waves, like the rhythm that's lulling you towards sleep, the steps beneath. Your feet are marvels of engineering in their own right. Modern escalator steps are typically made of die-cast aluminum, chosen for its perfect balance of strength and lightweight. Each step is designed to support heavy loads, usually around 600 pounds per step, which means a single escalator step could support several people standing on it at once. The surface of each step is covered with grooves. You can picture them. Now those parallel ridges running from left to right across the step. These grooves serve multiple purposes. First, they provide traction, preventing your feet from slipping. Second, they allow water to drain away if the escalator is in an outdoor or semi-outdoor location. Third, they give the step structure and rigidity, like the corrugations in cardboard. The edges of the steps have yellow lines. These bright strips of color are called demarcation lines, and they serve an important safety function. They make the edge of each step clearly visible, helping people judge where to place their feet. The yellow color was specifically chosen because it has high contrast against the gray or silver aluminum and is easily visible even in low light conditions. At the sides of each step, there are special combs, small tooth-like projections that interlock with matching combs at the top and bottom landings. These combs serve a crucial safety purpose. They ensure that nothing gets caught between the moving steps and the stationary floor. No shoelaces, no clothing, no small fingers. The combs mesh together like a zipper, creating a barrier that keeps everyone safe. As you continue your gentle rise, let yourself appreciate these safety features. Every aspect of the escalator has been designed with care, tested extensively, and regulated strictly. There are safety standards and codes that govern everything from the width of the steps to the height of the handrails, from the speed of movement to the emergency stop mechanisms. Speaking of emergency stops, every escalator has multiple safety systems. There's an emergency stop button, usually bright red, located at both the top and bottom of the escalator. If pressed, it cuts power to the motor and engages a brake, bringing the escalator to a smooth halt within a few feet. There are also automatic sensors that detect if something becomes caught in the machinery or if someone falls. These sensors can stop the escalator immediately, preventing injury. The handrails, too, have safety features. If the handrail moves too far out of sync with the steps, either faster or slower, sensors detect this and stop the escalator. This prevents people from being pulled forward or held back by the handrail. The system is always monitoring, always protecting, always ensuring your safety as you rise. As you ascend ever higher on this infinite escalator, let's travel around the world, visiting some of the most remarkable escalators ever built. Close your eyes and let your imagination carry you to these distant places. First, we travel to Hong Kong, to the mid-levels escalator system. This isn't just one escalator, it's a series of 20 escalators and 3 moving walkways, all connected together, stretching for 2,600 feet through the steep hillside neighborhoods of Hong Kong Island. It's the longest outdoor covered escalator system in the world. Imagine riding this escalator. You begin in the Central District, the bustling heart of Hong Kong's business area. You step onto the first escalator and it carries you upward, out of the concrete canyons of skyscrapers and into the residential neighborhoods that cling to the hillside. The escalator is covered with a roof to protect riders from Hong Kong's frequent rain, but the sides are open, giving you views of the city below. As you rise higher and higher, you pass shops and restaurants, old tenement buildings and modern apartments. The escalator system takes about 20 minutes to travel its full length, 20 minutes of effortless climbing that would otherwise require a steep, exhausting walk up countless stairs. The system was built in 1993 and carries about 85,000 people per day. Feel yourself on that Hong Kong escalator now. The humid air of the subtropical city surrounds you. You can smell food cooking in nearby restaurants, dim sum, roast duck, noodle soup. You hear the sounds of the city, cars honking, people talking in Cantonese, the rattling of air conditioning in units. But through it all, you hear that steady hum of the escalator motor, that reliable rhythm that carries you upward. Now let's travel to another remarkable escalator, the one in the Prague metro. Deep beneath the streets of this beautiful Czech city, in the Náměstí Míru metro station, you'll find the longest escalator in the European Union. It's 87 meters long, that's about 285 feet, and it rises at a steep 30-degree angle, carrying passengers between the street level and the subway platforms far below. Picture yourself on this escalator. You've just entered the metro station, and before you is this incredibly long escalator descending into the earth. The walls on either side are tiled in a pattern typical of Soviet-era metro construction. Simple, functional, but with a certain stark beauty. As you step on and begin your descent, you realize this is going to take a while. The ride lasts approximately 2.5 minutes. 2.5 minutes on an escalator. It seems like a long time until you experience it. At first you might look around, watching other passengers, reading the advertisements on the walls. But soon, the length of the ride induces a kind of meditative state. You're moving, but not through your own effort. You're descending deeper and deeper beneath the city, but safely, steadily, without any concern. The escalator carries you down, down, down. Above you, life continues in Prague. Tourists crossing the Charles Bridge, the astronomical clock chiming the hour, trams rattling through the streets. But here, in this tunnel, time seems different. The escalator's rhythm becomes your world. The hum of the motor becomes a kind of mantra. By the time you reach the bottom, you're completely relaxed, ready to step onto the train that will carry you to your destination. Let yourself continue rising on your escalator journey. Your breathing is becoming slower now, deeper. Your body is releasing tension with each breath out. As you rise, let's explore more about how escalators keep you safe. Because there's something deeply comforting in understanding the care that has gone into your protection. Every escalator is required by law to have a braking system that can bring the escalator to a stop, even if it's carrying a full load of passengers. The brake must be able to engage within a distance equal to the length of 1 or 2 steps. This means if something goes wrong, the escalator doesn't coast to a stop, it halts almost immediately. The brakes work through a combination of mechanical and electromagnetic systems. When power is cut or an emergency stop is activated, spring-loaded brake pads engage against a brake disc attached to the main drive shaft. The springs provide the force. They're always trying to push the brake pads into contact with the disc, and it's only the presence of electrical power that holds them back. This is called a fail-safe design. If power fails, the brakes automatically engage. There's also something called a governor, a device that monitors the speed of the escalator. If the escalator ever begins moving faster than its design speed, perhaps because of a mechanical failure, the governor detects this and immediately triggers the braking system. The governor is typically set to activate if the speed exceeds the normal rate by more than 20%. The steps themselves are designed to withstand extraordinary forces. Engineers calculate what they call the ultimate tensile strength of each component. For the step chains, this strength is typically around 200,000 pounds of force. That means it would take a pulling force of 100 tons to break one of those chains. And there are redundant chains. If one chain broke, which is extraordinarily unlikely, the other chains would still hold. Every moving part is regularly inspected. In most jurisdictions, escalators must be inspected monthly by qualified technicians. These technicians check the chains for wear, test the brakes, verify that all safety sensors are working, examine the steps for damage, and lubricate the moving parts. They keep detailed logs of these inspections. The handrails, too, are engineered for safety. Inside that rubber canvas composite, there are steel cables, typically 4 or 5 cables running the entire length of the handrail. These cables have a braking strength of about 10,000 pounds each. The handrail could easily support the weight of many people pulling down on it, even though it's only meant to be lightly touched for balance. Feel that handrail beneath your hand now. Feel its strength, its reliability. It moves at exactly the same pace as your steps, synchronized perfectly, through a system of gears and tension wheels. If the handrail stretches over time, as rubber naturally does, tension wheels automatically adjust, maintaining the perfect synchronization. Listen now to the sounds of the escalator. In your imagination, let these sounds surround you. Comfort you. The primary sound is the hum of the motor, that steady, droning tone at 60 Hz, the frequency of the electrical current. This sound is so constant, so unchanging, that your brain begins to filter it out, the way you stop hearing the sound of a fan after it's been running for a while. Beneath the motor hum, there's another sound, the whisper of the steps moving along their tracks. Each step has 4 wheels, and each wheel makes a quiet sound as it rolls. Multiply this by all the steps on the escalator, typically 80 to 100 steps in a standard installation, and you get a gentle, continuous rustling, like leaves in a soft breeze. There's also the sound of the chain drive, a quiet clicking as each link of the chain passes over the teeth of the sprockets. This sound has a rhythm to it, a regular pulse that matches the movement of the steps. If you listen carefully, you might be able to count the clicks, though soon they blend together into kind of mechanical music. The handrail makes its own quiet sounds. There's a soft squeaking or squealing sometimes, caused by the rubber moving against the guide rails that keep it on track. This sound is perfectly normal and harmless. It's the sound of the rubber gripping the rails, maintaining its course. Technicians adjust the tension of the handrail to minimize this sound, but a little bit of squeaking is acceptable and expected. At the top and bottom of the escalator, there are additional sounds. The combs make a clicking sound as they mesh and unmesh with the steps. The steps themselves make a clunking sound as they transition from flat to angled or vice versa, their wheels following the track transitions. These sounds mark the beginnings and endings, the points of transformation where steps emerge and disappear. All of these sounds together create what engineers call the acoustic signature of the escalator. Every escalator has its own unique signature, its own particular combination of sounds that depends on its age, its maintenance, the materials it's made from, and the environment it's in. Experienced technicians can diagnose problems just by listening to these sounds. A change in the motor hum might indicate a bearing wearing out. An irregular clicking might suggest a chain link is damaged. A change in the handrail squeak might mean the tension needs adjustment. But to you, the rider, these sounds are simply part of the experience. They're the soundtrack of your journey, the mechanical lullaby that accompanies your rise. Let these sounds wash over you now. Let them become part of your breathing, part of your heartbeat, part of the rhythm that's carrying you towards sleep. As you continue your endless ascent, let's think about how escalators have changed and improved over more than a century of use. The basic principle remains the same, a chain drive system pulling steps in a continuous loop. But nearly every component has been refined and perfected. Early escalators had wooden steps. Can you imagine? The steps were crafted from hardwood, usually oak, and they wore out relatively quickly with constant use. The wood would become smooth and slippery, particularly when wet. Step surfaces had to be replaced every few years. By the 1950s, most escalator manufacturers had switched to aluminum steps, which last much longer and maintain their traction better. The motors have changed dramatically. Early escalators used large, inefficient motors that consumed a lot of electricity and generated significant heat. Modern escalators use variable frequency drives that can adjust the motor speed based on load. When the escalator is empty or lightly loaded, the motor can run slower, saving energy. When sensors detect passengers waiting to board, the motor speeds up to full speed. Some newer escalators even have regenerative braking systems, similar to those in hybrid cars. When the escalator is going downward and heavily loaded, when gravity is helping to move the steps, the motor can act as a generator, converting that kinetic energy back into electricity that feeds back into the building's electrical system. This can reduce the energy consumption of an escalator by 30% or more. The handrails have evolved too. Early handrails were often made of leather or woven fabric. These materials wore out quickly and could become unsanitary. Modern handrails use synthetic rubber compounds that are more durable, easier to clean, and resistant to microbial growth. Some handrails are now treated with antimicrobial additives that actively kill bacteria and viruses on contact. Lighting has changed as well. Modern escalators often incorporate LED lighting, both for energy efficiency and for effect. Some escalators have lights embedded in the step risers, the vertical portions between each step, creating a gentle glow that makes each step clearly visible. Others have lighting in the skirting panels, the side walls of the escalator, providing ambient illumination. Safety features have been continuously added and improved. Modern escalators have more sensors than ever before. There are sensors that detect if someone has fallen. These use infrared beams or pressure plates at the top and bottom of the escalator. There are sensors that detect foreign objects in the machinery. There are sensors that monitor step chain tension, handrail speed, and motor temperature. Some escalators now have automatic start-stop systems. When no passengers are detected for a certain period, usually 60 to 120 seconds, the escalator automatically stops, saving energy. Motion sensors detect when someone approaches, and the escalator automatically starts up, reaching full speed before the person steps on. Let yourself appreciate this evolution, this constant improvement. Every component of the modern escalator is the result of thousands of hours of engineering work, countless tests and refinements, and more than a century of operational experience. You're riding on the accumulated knowledge of generations of engineers, mechanics, and designers, all working to make your journey safer, smoother, and more comfortable. There's something deeply psychological about escalators, something that affects us at a subconscious level. Let yourself feel this as you continue to rise, step after step, in this endless climb. When you step onto an escalator, you're surrendering control. You're trusting the machine to carry you. This act of trust is small but significant. In most of life, you're in control of your movement. When you walk, you decide each step. When you climb stairs, you control your pace, your rhythm. But on an escalator, you surrender that control. The escalator moves at its own pace, and you move with it. For some people, this surrender is difficult. They grip the handrail tightly. They watch their feet carefully. They tense their muscles as if preparing to catch themselves. But for others, the surrender is a relief. They relax, letting the escalator do the work. They look around, observe their surroundings, or lose themselves in thought. There's research on this. Psychologists have studied how people behave on escalators. Most people, when they first step on, look at their feet, making sure they've successfully boarded. Then, within a second or two, they look up and ahead. Some people stand still, letting the escalator carry them. Others walk, using the escalator to supplement their own movement. Studies show that about 75% of escalator riders stand still, while 25% walk. Interestingly, there are cultural differences. In countries like Japan and England, there's a social convention. Stand on one side of the escalator, usually the left in Japan, the right in England, leaving the other side clear for people who want to walk. This unwritten rule is followed religiously in some cities, to the point where standing on the wrong side might earn you disapproving looks or even verbal reminders. The act of riding an escalator creates a unique mental state. You're in motion, but not through your own effort. You're going somewhere, but slowly enough that there's time to think, to observe, to simply be. It's a kind of enforced pause in the rush of modern life. You can't make the escalator go faster. Well, you could walk, but even then, your speed is limited. You have to accept its pace. This is why escalators can be meditative. The steady motion, the inability to rush, the surrender of control, all of these factors encourage a kind of mindfulness. You become aware of the present moment. You notice things you might otherwise overlook. You might observe the architecture of the building, the faces of other passengers, the play of light through a window. Some people find escalators calming for exactly this reason. After a stressful day, after rushing from place to place, stepping onto an escalator forces you to slow down. You can't hurry. You can only ascend at the escalator's pace, breathing, relaxing, letting go. Let yourself feel this now. Feel how the escalator's rhythm is slowing your thoughts, calming your mind. There's nowhere you need to rush to. No decision you need to make. The escalator knows where it's going. All you need to do is stand and let it carry you upward, ever upward, toward rest, toward peace, toward sleep. As you rise higher still, let's dream about the future of escalators, about the innovations that it may come. Engineers are always imagining new possibilities, always pushing the boundaries of what's possible. Some researchers are working on escalators that can change their angle of incline. Current escalators are built at a fixed angle, typically 30 or 35 degrees. But what if an escalator could adjust its angle based on the needs of its users? It could flatten during busy times, when many people are boarding, then steepen during quiet periods for more efficient vertical transport. The technology is complex. It would require flexible support structures and sophisticated control systems. But it's theoretically possible. Others are exploring spiral escalators. Most escalators move in a straight line, but some buildings could benefit from escalators that curve. The challenge is enormous. The steps would need to be trapezoidal rather than rectangular, wider on one side than the other to accommodate the curve. The chain drive system would need to curve as well. Only a few spiral escalators have ever been built, and they're incredibly expensive. But they represent an elegant solution for certain architectural situations. There's research into energy recovery. As mentioned earlier, some escalators can already capture energy through regenerative braking when moving downward with a heavy load. But engineers are exploring other possibilities. What if the weight of passengers themselves could be harvested for energy? Each person stepping onto an escalator exerts a force. Could that force drive a small generator? The amount of energy would be small, but multiplied across millions of riders per year, it could add up. Some designers are reimagining the aesthetics of escalators. Why should escalators always look industrial, metallic, mechanical? What if the steps were made of glass, lit from within? What if the handrails were leather or wood, or some futuristic material? What if the entire escalator could change colors, responding to time of day or the mood of the space? There's even research into artificial intelligence for escalators. An AI system could learn the patterns of traffic in a building. When rush hours occur, when quiet periods happen, which escalators are most heavily used. It could adjust the operation of all the escalators in the building to optimize energy use, minimize wait times, and even predict maintenance needs before problems occur. Imagine an escalator that knows you're coming. As you approach from across the lobby, sensors detect your presence. The escalator starts up, accelerating smoothly to full speed just as you arrive to step on. Your journey is seamless, effortless. And after you disembark, the escalator slows down again, conserving energy, waiting patiently for the next passenger. But even as technology advances, the fundamental beauty of the escalator remains unchanged. It's still a chain drive system, still a loop of steps, still a machine that trades electricity for height, carrying you upward without effort on your part. The core genius of Jesse Reno's and Charles Seeberger's inventions endures over a century later. Let yourself rise higher still, and as you do, consider the vast network of escalators that exists around the world. There are escalators operating right now, at this very moment, in nearly every country on Earth. In New York City alone, there are more than 300 subway stations, many of them containing multiple escalators. Some of these escalators are ancient. By modern standards, installed in the 1970s or earlier, still faithfully carrying passengers up from the platforms. Others are brand new, featuring the latest technology and safety systems. In Tokyo, the metro system contains thousands of escalators. The stations are often deep underground. Tokyo sits in an earthquake-prone region, so many subway lines are built far below the surface for stability. Escalators carry commuters up and down, an essential part of the daily journey for millions of people. In London, the tube system has some of the longest escalators in the world. The escalator at the Angel station is 60 meters long and rises 27.5 meters vertically. It takes about 2 minutes to ride from bottom to top. During rush hour, this single escalator carries thousands of people every hour, each of them standing patiently, ascending in a slow procession. In Dubai, the malls are cathedrals of consumption, filled with escalators that sparkle with lights and polish. The Dubai Mall alone has dozens of escalators, carrying shoppers between its multiple levels. These escalators are maintained to a high standard. In the desert heat, air conditioning is essential, and the mall's escalators operate in climate-controlled comfort. In São Paulo, in Mumbai, in Mexico City, in Lagos, in Paris, in Toronto, in Sydney. Everywhere you go, you'll find escalators. They're in shopping malls and airports, in train stations and office buildings, in museums and stadiums. They've become an invisible infrastructure, so common that we barely notice them, yet so essential that their absence would be immediately felt. Think about this invisible network. At any given moment, millions of people around the world are riding escalators. They're ascending to their offices, descending to subway platforms, rising toward airplane gates, moving between floors of department stores. The escalators hum continuously, their motors turning, their chains pulling, their steps moving in endless loops. And each of these millions of escalators had to be designed, manufactured, transported, installed, and maintained. Each one represents the work of dozens or hundreds of people. Engineers who designed the components, factory workers who assembled them, truck drivers who delivered them, construction workers who installed them, technicians who maintained them. When you ride an escalator, you're benefiting from this vast network of human effort and ingenuity. You're standing on the shoulders of everyone who contributed to that machine's existence. Your effortless ascent is made possible by the accumulated work of countless others. Let yourself continue rising, and as you do, let's think about the people who keep escalators running, the maintenance technicians who ensure your safe passage. These technicians are specialists. They typically train for years, learning the intricacies of escalator systems. They need to understand electrical systems and mechanical systems, hydraulics and pneumatics, sensors and control systems. They need to be able to diagnose problems, from subtle symptoms, a slight change in sound, a barely perceptible vibration, a minor variation in speed. A maintenance technician might visit each escalator under their care once a month. They arrive early in the morning, before the building opens, or late at night after it closes. They carry toolboxes filled with specialized equipment, wrenches and screwdrivers, multimeters and oscilloscopes, lubricants and cleaners. First, they listen. They stand at the bottom of the escalator and listen to it run. That motor hum, is it the normal pitch or has it changed? Those chain clicks, are they regular or is there a hitch? The handrail squeak, is it the familiar sound or something different? Then they look. They walk alongside the escalator, examining every visible component. Are the steps damaged? Are the combs intact? Is the handrail showing signs of wear? They look for trash or debris that might have fallen into the mechanism. They check the yellow demarcation lines, making sure they're still bright and visible. Next comes the hands-on inspection. They stop the escalator and open access panels, revealing the machinery beneath. They check the chain tension. Too loose, and the steps won't move smoothly. Too tight, and components wear out faster. They examine sprockets for wear, looking for teeth that have become rounded or damaged. They test the brakes, making sure they engage properly. They check all the sensors, triggering them deliberately to verify they work. They test the emergency stop buttons. They measure the synchronization between steps and handrail, adjusting if necessary. Then comes lubrication. They apply grease to the chains, oil to the bearings, lubricant to the tracks. The choice of lubricant matters. Too thick, and it won't flow properly in cold weather. Too thin, and it won't provide adequate protection. Different parts require different lubricants, and the technician knows exactly which product to use where. Finally, they clean. They vacuum out dust and debris from the machinery. They wipe down the handrails with disinfectant. They clean the step surfaces, removing gum and stains. They make the escalator look as good as new, ready for another month of faithful service. This work is invisible to most riders. You step onto an escalator and expect it to work, never thinking about the technician who inspected it just days or weeks ago. But that technician's work is essential. Without regular maintenance, escalators would break down frequently. Parts would wear out prematurely. Safety systems would fail. The reliability you take for granted depends on these skilled professionals, doing their work diligently, regularly, often in the middle of the night when you're asleep. As you rise ever higher, let's consider the mathematics that governs escalator operation. There's a beautiful logic to how escalators move people, a set of equations and calculations that determine everything from the width of the steps to the speed of movement. Engineers call it transport capacity, how many people an escalator can move in a given period. This capacity depends on multiple factors. First is the speed of the escalator. As mentioned earlier, most escalators move at about 0.5 meters per second or 30 meters per minute. Some move slightly slower, 0.4 meters per second, particularly in locations where elderly or disabled passengers are common. Others move faster, up to 0.75 meters per second, in locations where most riders are young and able-bodied. Next is the step width. Standard escalators have steps that are either 600 millimeters wide, about 24 inches, or 1,000 millimeters wide, about 40 inches. The wider steps can accommodate two people standing side by side, effectively doubling capacity compared to narrow steps. Then there's the spacing between riders. Safety regulations require that escalators be designed assuming each person occupies one step. In practice, people often stand closer together, sharing steps. But the design must account for the worst case, one person per step. Combining these factors, engineers calculate capacity. A standard 600 millimeter wide escalator moving at 0.5 ms with one person per step and steps spaced 0.4 meters apart can theoretically transport about 4,500 people per hour. A wider 1,000 millimeter escalator at the same speed, with people standing two abreast, could transport 9,000 people per hour. But these are theoretical maximums. In practice, capacity is lower because people don't board the escalator continuously. There are gaps in the flow of passengers. At busy times, capacity might reach 70 to 80% of the theoretical maximum. At quiet times, it might be only 10 to 20%. This mathematics influences building design. Architects and engineers must calculate the expected foot traffic in a building, then design an escalator system that can handle peak loads without excessive waiting. A shopping mall on Black Friday needs much more escalator capacity than the same mall on a Tuesday morning in February. Interestingly, there's an optimal point where adding more escalators doesn't help. If a building has too many escalators, they spread the passenger load too thinly, and it becomes less efficient than having fewer, fuller escalators. There's a sweet spot, and finding it requires careful analysis of traffic patterns and passenger behavior. The mathematics also governs energy consumption. Power usage is proportional to the weight being lifted and the height. An escalator carrying 100 people, weighing an average of 70 kilograms each, 7,000 kilogram total, up a height of 10 meters, requires about 190,000 joules of energy. At 0.5 ms, the journey takes 20 seconds, so the power requirement is about 9,500 watts, or about 13 horsepower. But motors aren't perfectly efficient. A typical escalator motor might be 85% efficient, meaning 15% of the electrical energy is converted to heat rather than motion. So that 9,500 watts of lifting power requires about 11,200 watts of electrical input, or about 11 kilowatts. For an escalator running 16 hours a day, that's about 176 kilowatt hours per day, or about 64,000 kilowatt hours per year. At typical commercial electricity rates, that's roughly $6,400 per year just to power one escalator. For a large building with many escalators, the energy costs quickly add up to substantial sums. This is why energy efficiency matters. Reducing power consumption by even 10% could save thousands of dollars per year per escalator. This is why automatic start-stop systems are becoming common and why regenerative braking is being implemented. The mathematics of energy savings justifies the investment in newer, more efficient technology. Let these numbers wash over you. Don't try to remember them or calculate with them. Just let them exist in your mind, a testament to the careful thought that goes into escalator design. Every escalator you've ever ridden has been the subject of these calculations, these optimizations, these careful considerations of capacity and energy and cost. As you continue your gentle ascent, let's think about the people who work in buildings with escalators, who ride the same escalators day after day, year after year. Imagine you work in an office building on the 10th floor. Every morning you arrive at the building, you walk through the lobby and approach the escalators. You've done this hundreds or thousands of times before. The escalator is familiar, almost a friend. You know its rhythms, its sounds, its quirks. You step on without thinking, your body automatically timing the step to match the moving tread. Your hand finds the handrail without looking. You rise, and as you do, your mind is already shifting into work mode. The escalator ride is a transition, a liminal space between home and office, between personal life and professional responsibility. You might encounter co-workers on the escalator. There's an etiquette to these encounters. A nod, perhaps a greeting. Maybe a brief comment about the weather or the workday ahead. But not a full conversation. The ride is too short, and there's something about the public nature of the escalator that discourages deep discussion. At the top, you step off smoothly, your body knowing exactly when to lift your foot. You proceed to the elevator that will take you to your floor. The escalator has done its job, carrying you from the ground floor to the lobby level, the first stage of your vertical journey through the building. And then, 8 or 9 hours later, you do it again in reverse. You descend on an escalator, heading home. If you're lucky, you might get to walk. The escalator helps you move a bit faster, supplementing your own motion. If you're tired, you stand and let the escalator do all the work, grateful for the rest. For retail workers, escalators are even more present. If you work in a multi-floor department store, you might ride the escalators dozens of times per day, moving between departments, helping customers, restocking shelves. The escalators are your constant companions, always there, always moving, at least during business hours, always ready to carry you where you need to go. Some workers develop deep familiarity with their building's escalators. They know which one is slightly faster. They know which handrail is smoother. They know which one gets the most sun in the afternoon, making it warmer. They have preferences, favorites, the way you might have a favorite chair or a favorite coffee mug. And when an escalator breaks down, which despite all the maintenance does occasionally happen, these workers feel its absence keenly. Suddenly, they have to take the stairs, and the extra effort is noticeable. Or they have to use a different escalator, one that's more crowded, slower, less convenient. The broken escalator becomes a topic of conversation. Did you hear? The west escalator is out. They're saying it'll be fixed by Thursday. Let yourself appreciate the role escalators play in these workers' lives. For you, an escalator might be an occasional convenience. But for them, it's daily infrastructure, as essential as the elevator or the restroom or the coffee maker. They depend on it, trust it, and notice when it's gone. As you rise still higher, let's consider how escalators shape the buildings they're in. Architecture and escalators influence each other in fascinating ways. Before escalators, multi-story buildings had to be designed around staircases. Grand. Staircases were central features, often placed prominently in the main hall or lobby. These staircases were wide, ornate, designed to impress. But they were also space-consuming and limited in capacity. Escalators changed everything. Suddenly, it became practical to build larger, more spread-out, multi-story buildings. Department stores could expand horizontally across their upper floors because customers could easily reach those floors via escalators. The stairs could be relegated to secondary locations, used mainly for emergencies or by the few people who preferred to walk. Escalators also enabled new architectural experiences. Shopping malls in particular took advantage of escalators to create soaring, multi-story atriums. Escalators could run up the middle of these open spaces, visible from all floors, creating a sense of movement and energy. Shoppers riding the escalators could see multiple floors at once, getting a view of the mall's offerings and perhaps being tempted to visit floors they hadn't originally planned to. Some buildings use escalators as architectural centerpieces. The Centre Pompidou in Paris, for example, has escalators enclosed in glass tubes running up the exterior of the building. As visitors ride these escalators, they get increasingly panoramic views of Paris, with the cityscape unfolding below them. The escalators aren't hidden away. They're celebrated, turned into an experience in themselves. The Louvre Museum in Paris has an escalator experience of a different sort. In the modern glass pyramid entrance, escalators carry visitors down to the below-ground lobby. The escalator descends through the middle of the pyramid, surrounded by glass, natural light filtering in from above. It's a dramatic entrance, a transition from the historic exterior courtyard to the modern interior facilities. In Asia, many buildings take escalator design to artistic levels. Escalators might be flanked by water features with fountains or artificial streams running alongside. Or they might be surrounded by gardens with plants and flowers, creating a sense of moving through nature as you ascend. The escalators become part of a holistic design vision, integrating mechanical function with aesthetic beauty. Think about the buildings you've been in, the escalators you've ridden. How did they fit into the architecture? Were they prominent or hidden, modern or traditional, purely functional or aesthetically designed? Each building makes choices about how to incorporate escalators, and those choices reflect the building's purpose and the designer's vision. Let your mind wander through these spaces now. Picture yourself in a gleaming shopping mall, escalators rising through the center of a vast atrium. Picture yourself in a subway station, an escalator carrying you up from the dark tunnels toward daylight. Picture yourself in an office tower, a series of escalators connecting the lobby to the conference levels. Each space is different, but the escalator serves the same fundamental purpose: lifting you upward, effortlessly, reliably, safely. As you continue this infinite ascent, consider how escalators quietly revolutionized accessibility. Before escalators, multi-story buildings were significant barriers for anyone with mobility limitations. Elderly people, people with disabilities, parents carrying children. For all of them, stairs were a challenge or even an impossibility. Escalators didn't completely solve this problem. Elevators are more universally accessible, as they can accommodate wheelchairs, but they dramatically improved matters. Someone who can stand but who finds climbing stairs difficult or painful can ride an escalator comfortably. The escalator does all the work. This had social implications. Department stores became more accessible. Train stations became more usable. Public buildings opened up to a broader range of people. The escalator was a democratizing technology, making vertical space available to nearly everyone. Modern escalator design continues to prioritize accessibility. The steps are designed to be deep enough that people can stand stably. The handrails are at a height that's comfortable for people of various sizes. The speed is slow enough that boarding and exiting are manageable for most people, even those with limited mobility or balance issues. Some escalators are specifically designed with accessibility in mind. These might run at slower speeds, 0.3 or 0.4 meters per second instead of 0.5. They might have extra deep steps or wider landings at the top and bottom. They might have additional handrails or grips. There's ongoing research into making escalators even more accessible. Some experimental designs include seats that could fold out from the escalator's side, allowing people to sit as they ascend. Others include platforms that could accommodate wheelchairs, though this technology is complex and not yet widely implemented. The escalator also serves as a backup to elevators. In a building where the elevators are crowded or broken, People who can use escalators have an alternative. This redundancy is valuable. It means the building's vertical circulation doesn't depend on a single system. For children, escalators can be their first experience with powered transportation. Before they're tall enough to reach an elevator button, they can ride an escalator, holding a parent's hand. It's a thrilling experience for many children. The moving steps, the gentle rise, the sense of effortless motion. For some kids, riding the escalator is the highlight of a shopping trip. Of course, escalators also require caution, especially for children. Parents are taught to carry small children or hold their hands firmly. Kids are instructed not to sit on the steps or play on the escalator. The combs at the edges, designed to prevent entrapment, can still be a hazard if children put their fingers near them. Safety is always a concern, but overall, escalators have made buildings more accessible, more navigable, more democratic. They've allowed architecture to go vertical while remaining open to most people. This quiet revolution in accessibility is one of the escalator's great achievements. Let your mind drift now as you continue to rise. Escalators have entered our culture, our language, our collective imagination in interesting ways. The word escalate now means to increase or intensify, but it comes from the escalator. To escalate a situation is to take it to a higher level, just as an escalator takes you to a higher floor. The escalator gave us a metaphor for intensification, for raising the stakes, for moving upward in conflict or drama. Escalators appear often in films and television. They're visually interesting, the constant motion, the geometric patterns, the interplay of levels. Filmmakers use escalators to create specific moods or to symbolize certain ideas. In romantic comedies, characters might have significant conversations while riding escalators, moving toward or away from each other literally as well as figuratively. In action films, escalators provide opportunities for dramatic chases, with heroes running up, down escalators or villains sliding down handrails. In horror films, a broken or malfunctioning escalator can be a source of danger, its mechanisms turning sinister. One of the most famous escalator scenes in cinema is in the department store chase in the film Elf. The main character, Buddy, unused to modern technology, treats the escalator with wonder and fear, approaching it tentatively before finally boarding. His childlike amazement reflects how revolutionary escalators once seemed and how we now take them for granted. Another memorable escalator scene appears in The Matrix Reloaded, where a fight sequence takes place in a multi-level building with escalators. The escalators provide a dynamic environment, moving platforms that change the geometry of the fight as it progresses. Escalators also appear in dreams. Dream researchers have found that escalators are common dream symbols. Riding an escalator upward in a dream often represents progress, advancement, success. Riding downward might represent regression or loss of status. A broken escalator might represent obstacles or frustration. Like many dream symbols, the meaning depends on context and the dreamer's personal associations. In literature, escalators sometimes symbolize modern life. Automated, efficient, carrying us along whether we will it or not. They can represent the passage of time, the inexorable forward motion of life. In science fiction, they sometimes appear as representatives of advanced technology or of civilizations that have mastered convenience and efficiency. Escalators have inspired artists too. Photographers love escalators for their geometric beauty, the converging lines, the patterns of steps and light. Painters have used escalators to represent modernity, urbanity, the intersection of human and machine. Sculptors have created escalator-inspired works, playing with themes of ascent and descent, of mechanical motion and human passivity. There's something universally relatable about the escalator experience. Almost everyone in the developed world has ridden one. The sensation is familiar, the sound is recognizable, the sight is instantly identifiable. This shared experience makes escalators potent cultural symbols, shorthand for modern life and urban existence. As you continue your ascent, think about your own escalator memories. Your first ride, perhaps. A particular escalator in a place that matters to you. an escalator in a mall you visited as a child, or in a subway station you use regularly, or in an airport during a memorable trip. These memories are part of the escalator's cultural impact. It's not just a machine, but a repository of experiences, a background character in countless personal stories. You're still rising, always rising, on this endless escalator. As you ascend, let's think about how the future arrives through technologies like escalators. Not suddenly, but gradually, almost imperceptibly. When the first escalators appeared at the turn of the 20th century, they seemed miraculous. People couldn't believe a machine could carry them upward without effort. But within a few decades, escalators became commonplace. They were installed in buildings everywhere. The miracle became mundane. This is how most technological progress happens. A revolutionary innovation appears, generates excitement and wonder, then slowly becomes so normal that we forget it ever seemed special. Our grandparents marveled at escalators. We barely noticed them. The same pattern applies to countless other technologies. Automobiles were once wonders, now they're everywhere. Airplanes were once incredible, now we complain about flight delays. Computers were once room-sized marvels. Now we carry more computing power in our pockets than existed in the entire world in 1950, and we use it to look at photos of cats. Escalators remind us of this pattern. They're over a century old, but they still work basically the same way they did when Reno and Charles Seeberger invented them. Yes, the materials are better, the motors are more efficient, the safety features are more sophisticated. But the core concept, a chain-driven loop of steps, remains unchanged. This is actually a mark of excellent design. The escalator was so well conceived from the beginning that fundamental changes weren't necessary. Refinements and improvements, yes. Complete reimagining, no. The original inventors got it essentially right. Many of the best technologies follow this pattern. The wheel, invented thousands of years ago, still works the same way. The lever and the pulley, the screw, and the wedge. These simple machines haven't changed fundamentally since ancient times. A good solution, once found, can last indefinitely. As you rise on this escalator, consider what future technologies might follow the same path. What innovations happening now will seem commonplace to